Hi, I'm Adam.
Hi, I'm Francesca.
Today we will be discussing momentum,
Impulse
the law of conservation of momentum.
and collision.
So you may be wondering, what is momentum? Momentum is basically inertia in motion, which is a product of mass and velocity of an object. Don't forget, momentum is a vector quantity.
To understand the change in momentum, you must first understand the concept of impulse. Impulse is caused by a force acting over a period of time. So now you know, an impulse causes momentum to change.
So now to explain a collision.
A collision is the interaction of two objects.
Is that all you know about collisions?
No, the most important part of a collision is the interval of time it takes place in. Time is everything when it comes to a collision.
Now I'm going to explain the law of conservation of collision. The law of conservation of collision explains how momentum stays a constant when there is the absence of an outside force, meaning that the momentum and velocity will stay the same before and after an event has taken place.
For example, when you punch a wall, it may seem as though all momentum has been lost, but before jumping to any conclusions, think about where the momentum is going. The momentum from your punch is transferring into the wall, which is connected to the earth. You are unable to see this transfer of momentum because the earth is so large.
Here, I'll show you.
See?
There are three different types of collisions you should know about: elastic, inelastic, and explosion. An elastic collision is when objects rebound without lasting deformation. No damage is done, nor heat is generated. An example are these balls.
Now I'm going to show you momentum concerning the differences between weight. First, cork. Next, wood. Aluminum. Brass. Steel. And lastly, lead. Notice how the balls with more weight had more momentum. An inelastic collision is when objects collide and come deformed. Damage is done and they may possibly stick together, causing heat to be generated. For an example, a bullet being fired into a block of wood.
An explosion is when two or more parts of an object push off from each other. An example is an astronaut throwing a hammer in space.
There are some similarities between these three types of collisions. Both inelastic and explosion collisions generate heat and cause damages.
But don't forget, there are also many differences. An elastic collision is only collision that generates no heat, nor causes any damages, unlike the other two. So remember, momentum is always conserved.
Have a great day! A great way to help explain the strong relationship between momentum and time is to show you with two ordinary eggs. Ever find yourself wondering how an egg always seems to crack when thrown against a wall, but never seems to crack when thrown against a pillow or a sheet? It's all because of time. Here, allow me to demonstrate. The reason the egg cracks immediately after its collision with the wall is because there is an extremely small interval of time that the momentum of the egg has to stop in. Now let me help explain to you why an egg never cracks when thrown into a sheet or a pillow. For me to best help explain this to you, let me show you through another demonstration. Now I'm going to show you an egg being thrown into a pillow. Now for a close-up. The reason the egg doesn't crack when being thrown into a pillow or a sheet is because of the much longer interval of time. Don't forget about the equation we talked about earlier. Change in P, meaning the change in momentum, is equal to force multiplied by the time. The more time during a collision, the less likely there's to be any chances of any damages made. See, the pillow helps to absorb the momentum of the egg, causing for a less messy outcome.